Alrighty, so welcome back. We are going to be going over the homework and then continuing with our lectures on concavity. So let's jump straight to the homework. We had number 6 first, and number 6 was g of x is equal to 3x squared minus x cubed. Strange that that's not in standard order, but that's okay. So first things first, step 1. Are there any discontinuities? Absolutely none. Why? Because it's a polynomial. Step 2 then, we're going to move on to the critical numbers. So critical numbers, they require us to do something before we can look for them. What is that? Well, take the first derivative. So now we're going to have g prime of x is equal to, we're going to have 6x minus 3x squared. Okay? Now, part A, are there any discontinuities? Nope, because it's just a polynomial. It's not a rational expression or a root of some sort, so we don't have to worry about that. Part B, though, we set f, you want to do this multiple times since it's g and I'm not used to that. We're going to set g prime equal to 0, which implies that we're going to have 6x minus 3x squared equals 0. I'm going to reorder this and divide by negative 3x. So negative 3x times x minus 2 equals 0. And so I wind up with x equals 0 and x equals 2. Those are going to be my two critical numbers. All right. So next thing we do, well, let me clear this so we can make the table. So clearing that, step 3, the f prime table. Okay, and we're going to have 0 and 2. And so we need our f prime or g prime. I'm going to say it over and over. It's just going to happen. You didn't see anything. I still see g prime. This is just terrible. It shows how used to it I am working with f. So g prime of x was equal to, we had 6x minus 3x squared. Okay, so I need a test value that is less than 0. How about negative 1? Negative 1. So g prime of negative 1 equals, well, if I plug that in, I'm going to get a negative 6. That'll become a positive 1, so minus 3. Negative 6 minus 3 is definitely negative. So I have a slope that's going down. And then a value between 0 and 2. How about x equals 1? So here I'm going to get 6 minus 3. That is definitely positive. So g prime of 1 is positive. So I'm going to have a slope that's going up. And finally, I need a test value greater than 2. How about x equals 10? That's going to give me 60 minus 300. That is definitely negative. So it's going back down, which means that at x equals 0, I have a min because it's going down then up. And x equals 2, I have a max since it's going up and then down. Alrighty? So, step 4, inflection points. Okay, how do I find my inflection points? Well, I need to take the derivative of g prime, so this is going to be g double prime of x equals 6 minus 6x. Okay, there are no discontinuities. I told you didn't have to worry about that to begin with, but just out there, since that's a polynomial, that's an easy check. So what I am going to worry about, though, is where g double prime of x is equal to 0. So that's going to imply that 6 minus 6x equals 0. If I factored out a negative 6, I would be left with x minus 1. And so x equals 1 is an inflection point. Okay? So now I do the g double prime table for this one inflection point. So I've got x equals 1. I need a test value that is less than 1. How about 0? x equals 0 is going to be 6 minus 0, which is positive. So g double prime at 0 is positive. So I know I'm going to have concave up. Over here on this side, maybe x equals 10. So g double prime of 10. Well, that's going to be 6 minus 60, definitely negative, which is concave down. Alrighty, so now I can look for my y values for the next step. So let me clear this. So I've got step 6, the y values. I've got my inflection, no, not inflection points first, blah, blah, blah. Critical numbers first. So for the critical numbers, I had x equals 0 and x equals 2. So x equals 0. What am I doing with this value to find my y value? I'm plugging it into the original expression, which was, if I look at g of x, that is equal to 3x squared minus x cubed. So if I plug in 0 and do g of 0, I'm going to wind up with 0. So that point is located at 0, 0. Alrighty. Then I had another value at x equals 2. So g of 2 is going to equal, well, I'm going to have 4 times 3 is 12, minus 8 is going to be 4. So I'm going to have the value of 2, 4 for this one. Alrighty. And next I want to find my inflection points, where they're located into the, I don't know why I did that. I don't need an apostrophe for that. So they were located at x equals 1. And so g of 1 is equal to 3 minus 1 is 2. So I get the location at 1, 2. Okay? So now I'm ready to graph this thing. This is a pretty standard function, nothing crazy going on. Let's see, I'll go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Alrighty, so I have critical numbers at 0, 0, right there, and at 2, 4, right there. Okay? And then I have an inflection point at 1, 2. Alrighty, now from my tables, I am going, but for all the values that are less than x equals 0, I'm going down. And then between my x equals 0 and x equals 2, I had a slope going up, which that's lucky that. And then after x equals 2, I had a slope going down. What did the concavity look like? Well, everything to the left of x equals 1 was concave up. Everything to the right was concave down. And so we can actually build a nice little graph with this. Looks like it's going to do something like, oops, actually touch it, that. Where this is concave up, concave down, down, up, down for all the slopes. And that's it. And notice this happens quite a bit. This is kind of a sanity check. If I have a min and a max, there is usually an inflection point exactly in the middle of the x values. That makes sense because in order to transition from a min to a max, I have to have an inflection point, and usually it occurs right around the middle between the two x values. So there was an x value here at 0, here at 2, inflection was at 1. Just something to look out for. So there you have it. That was step 7, was graphing this thing, sketching the graph. Alrighty, so let's move on to the next homework problem. Let me clear the screen. Okay, so let's see, that was number 10. So number 10 was f of x equals 2x squared over 3x squared plus 1. Alright, so first off, let's go for step 1. are there any discontinuities? And the answer is no, because every value I put in for x gets squared, so it becomes positive times a positive plus a positive can never be 0. So there are no discontinuities. Okay, now I move on to step 2, the critical numbers. And for that, I need the first derivative. So f prime of x is equal to, this is a quotient, the bottom, 3x squared plus 1 times derivative of the top, 4x, minus the top, 2x squared, times derivative of the bottom, that's just going to be 6x, and then all of that is over the bottom squared. So 3x squared plus 1 quantity squared. Okay? So what do I get here? Well, I get 12x cubed plus 4x minus 12x cubed. Well, isn't that interesting? And then all of that is over the bottom squared. 3x squared plus 1 to the second power. These are going to cancel, and I'm going to be left with 4x over quantity 3x squared plus 1 squared. Alrighty, that is my f prime of x. Now, are there any discontinuities? There is no way I can make this a 0 because, again, I'm squaring any value in here and adding 1 to it. So positive plus 1 is never going to be 0. So I wind up with no discontinuities. Okay, and for part B, when I set f prime of x equals 0, well, that implies that I set the top equal to 0. 4x equals 0, x equals 0 is my critical number. Okay? So now we can move on to step 3. Let me clear the screen. So for step 3, we're going to do the f prime table. And so I only have one critical number, x equals 0. Give me a value that's less than x equals 0. How about x equals -1? And I'm going to have the function over here. F prime of x is equal to, I've got 4x over quantity 3x squared plus 1 squared. Okay, so f prime of -1 is going to equal, well, what do we get? A positive value down below, and then a negative value up top. It's going to be a negative, which means we're going to be heading down. The slope is heading down. Okay? Then a value greater than 0. How about x equals +1? Well, in that case, f prime of +1 is going to be a positive, and then a positive on top, which is going to be positive. So it's going to be heading up, which means what is x equals 0? It's going down, then up. So that means that this is a minimum. Alrighty, so now that I've got that taken care of, I can move on to step 4, finding my inflection points. Okay, for that I need f double prime. So f double prime of x is going to equal the bottom untouched 3x squared plus 1 quantity squared times derivative of the top, 4, minus the top, untouched, 4x, times derivative of the bottom. Here we go. That's going to be 2 times quantity, 3x squared plus 1 to the first power, times the derivative of the interior, which is just 6x. And all of that is going to be over 3x squared plus 1 to the fourth power. All right, like we did before with one of the previous ones, we can simplify this by dividing every single one of these terms by 3x squared plus 1. So that would drop this power to 3, it would drop this 2 to a 1, and it would make this whole thing the actual value 1. So much, much, much easier to work with. I'm going to get f double prime of x is equal to, so 3x squared times 4, 12x squared, 1 times 4 plus 4, and then I'm going to have minus, and then this is going to be 4x times 2, 8x, times 6x is going to be 48x squared, minus 48x squared, and then all of that over 3x squared plus 1 to the third power. So when I combine terms, I'm going to wind up with negative 36x squared plus 4 over 3x squared plus 1 to the third. Okay, so that's the second derivative. Now, are there any discontinuities? No, there are no discontinuities because I can't make this one go to 0, since again, this will always be a positive value. But what about f double prime of x equals 0? So f double prime of x equals 0, that implies that the top is equal to 0. So negative 36x squared plus 4 equals 0. Alrighty, I'm going to factor out a negative 4. So if I do that, negative 4 times 9x squared minus 1 equals 0. So I can now, you can imagine, I divide both sides by negative 4. That's going to get rid of that and still keep this at 0. So we'll wind up with 9x squared minus 1 equals 0. And so x has to be, well, how do I figure that out? Well, 9x squared is equal to 1. X squared is equal to 1/9. X is equal to plus or minus root 1/9, which is plus or minus 1/3. Okay? So my critical numbers are at x equals negative 1/3 and x equals positive 1/3. Those are the critical numbers. Oh, I'm sorry, not critical numbers, inflection points, inflection points. Alrighty, so these are inflection points. So now that I have figured that out, I can make my table. So let's do the f double prime table. Let me clear this. Clear this. Let's see, so step 5, I think it is. I think it's 5. We're going to do the f double prime table. So I'm going to have f double prime table. My two locations were at x equals negative 1/3 and x equals positive 1/3. Now I need a test value less than negative 1/3. How about negative 1? X equals negative 1. Well, in order to do this, I'm going to be plugging it into f double prime. But I need that written out here, so f double prime of x was equal to, let's see, what was it? It was negative 36x squared plus 4. And that was over 3x squared plus 1 quantity cubed. Right? So if I'm plugging negative 1 in here, I'm going to get, so that's going to become a positive 1 when I square it. It'll be a negative 36 plus 4 is a negative 32. So that's a negative 32 right here. This is going to become a positive 1. 3 times positive 1 is 3, plus 1 is 4. So I've got a negative 32 on top, and 4 cubed, which is what? 4 times 4 times 4 is 64. So negative 32 over 64 is going to be a negative. I don't know why I did all that math when I could have just said negative 1 here. That makes this negative on top and positive on the bottom, and then just should have just gone with that. So it's going to be a negative value for the f double prime of negative 1. So it's going to be concave down. Then a test value between negative 1/3 and positive 1/3. How about 0? I like that one. Plug a 0 in here, I get 4 and then over positive, so positive over positive. So f double prime of 0 is positive, which means it's concave up. And finally, a value greater than 1/3, how about x equals 1? F double prime of 1 is going to be, well, same thing, negative on top, positive on the bottom, negative. So it's going to be concave down. Okay, so that is my f double prime table. Now, part 6, I need the y values. Okay, like I said, I like to start with the crit numbers, so critical numbers. I'm going to have x is equal to, well, the critical numbers for this one, I only had one critical number, and that was at x equals 0. So at x equals 0, f of 0 equals, well, I need my original function, don't I? So my function was f of x equals 2x squared over 3x squared plus 1. Okay? So, not 2, looking a little rugged. There we go. That's sort of a 2. Now, if I plug 0 in, I get 0 over 1, which is 0. So this critical number is located at 0, 0. Then I look at my inflection points, and I'm going to have, first one is at x equals negative 1/3. Okay, so for that one, f of negative 1/3 gives me, all right, so this is going to be 1/3 squared is 9. So this is going to be 1/9 rather, 2/9, and this is going to be 3/9 plus 9/9, which is 12/9. So 2/9 over 12/9 is going to wind up being 2 over 12, which is 1/6. So I don't know why I did the print there. That's not needed. 1/6. Okay. I did that in my head, so double check me, but I think that's right. So this gives us a point of negative 1/3, 1/6. And then I do x positive 1/3 for the next inflection point, next y value. So f of positive 1/3 equals, well, they're squaring, so it's the same as the one above. So this is going to be 1/6 as well. So positive 1/3, 1/6. Alrighty. Now, I've got all of this, and I can now sketch the graph. So let me sketch the graph. So clear this. Step 7, sketch it. So here we go. I'm going to, I've got a lot of room, so here we go. I'm going to make this 1, 1, negative 1, and negative 1, something like this. Alrighty, so I had my critical number, which we said was a min, located at 0, 0. So it's right there. That's 0, 0. And then I had an inflection point at 1/3, 1/6. So something like right here. And then I had another one with negative 1/3, 1/6. So maybe right there. Alrighty, so what did this thing look like? Well, the slope was going down, then up, and the concavity was going down to the left of the first inflection point, up between the two inflection points, and then down again. Okay, so what does that look like? Well, that looks like this. That's terrible. You didn't see anything. There we go. Maybe something like that. Does that make everything work? Concave down, concave up, concave down, down slope, down up slope, and it's hitting the min value at 0, 0. Yep, that's what the graph looks like. Alrighty, woo, that was a lot. So let's clear this and start with a new example. So here we go. Clearing the board and starting a new example. Okay, so the first example is going to be, let's go with, f of x equals, we'll do x squared minus 1 over 2x minus 1. Okay, so first things first, are there any discontinuities? Yes, there are, finally. Where is the discontinuity? Well, I get the discontinuity when I set the denominator equal to 0 and solve. So 2x minus 1 equals 0. X equals 1/2. So at x equals 1/2, I have a discontinuity. What type of discontinuity is it? Is it a whole or a vertical asymptote? Well, if I plug 1/2 into the top, I get 1/4 minus 1. That is not 0. So bottom goes to 0, top doesn't. It is a vertical asymptote. Okay? So now we can move on to step 2, which is going to be the critical numbers. How do I find my critical numbers? I have to take the first derivative. So f prime of x is going to equal bottom, untouched, 2x minus 1, times derivative of the top, 2x, minus the top, untouched, x squared minus 1, times derivative of the bottom, 2, and then all of that over the bottom squared. So 2x minus 1 quantity squared. Okay? So now I can multiply this out and get 2x times 2x, 4x squared, minus 2x, minus 2x squared, and then minus negative 2, which is going to be plus 2. Okay? All of that over 2x minus 1 quantity squared. Okay? Well, I can do that. 4x squared minus 2x squared is going to be 2x squared minus 2x plus 2 over 2x minus 1 quantity squared. That's going to be my f prime of x. Okay? So, first things first, are there any discontinuities? Yeah, there's discontinuity at x equals 1/2 again. So I already had it. So there is a discontinuity, but already knew that. Anytime there's a discontinuity with the original function, there's going to be a discontinuity at that same location for the subsequent derivatives. So here we go. Now part B, I've got f prime of x equals 0, which implies that 2x squared minus 2x plus 2 equals 0. All right, I'm going to have to go to the next page for this, so I'll clear that. So I've got f prime of x equals 0, which implied 2x squared minus 2x plus 2 is equal to 0. Alrighty, and so now if I factor it, I'm going to divide everything by 2, because I can. X squared minus x plus 1 equals 0. Divide by 2, that this stuff goes away. I'm left with just x squared minus x plus 1 is equal to 0. So how do I solve that? Well, quadratic formula. A is equal to 1, B is equal to negative 1, C is equal to 1. X equals, here we go, negative B, so 1 plus or minus square root of B squared, which is negative 1 squared, minus 4 times 1 times 1, all of that over the, as I've done, b squared minus 4ac over 2a, so 2 times 1. Okay, so this is going to be x equals 1 plus or minus square root of, here we go, 1 minus 4, negative 3 over 2. I'm done. That is an imaginary value because I cannot take the square root of a negative number. So there are no critical numbers. What does that mean? It means there are no horizontal slopes to this one, which is totally fine. You can absolutely have that. And so with this expression now, I can now do, I've got my critical numbers taken care of. Now it's time to go for the double prime. So let's see. I've got, hold on, I've got to do my f prime of x up here so I can take double prime. Since I would normally do step, let's see, 1, 2, 3 would be the f prime chart. I don't have an f prime chart. There were no discontinuities other than the one I already knew about, which is the vertical asymptote, and there were no horizontal slopes. So f prime chart, I can skip it. There were no critical numbers. So I get to skip it. Skip. Alrighty, but f prime of x was equal to, well, we had 2x squared minus 2x plus 2 over 2x minus 1 quantity squared. Okay? So I can go to the inflection point. So step 4, inflection points. How do I find the inflection points? Well, I need the second derivative. So the second derivative of double prime of x is going to be bottom untouched 2x minus 1 quantity squared times derivative of the top. It's going to give me 4x minus 2 minus the top untouched 2x squared minus 2x plus 2 times derivative of the bottom, which is 2 times 2x minus 1 to the first power times the derivative of the interior, which is 2. I squeaked it in. So here we go. All of that is over the bottom part squared. So 2x minus 1 quantity to the fourth. Alrighty. This would be horrible, except once more, I can divide each of the terms by 2x minus 1. So if I do that, I get cubed here to the first power here, and this whole term goes to a 1, which makes me very happy, because now I have f double prime of x equal to, well, this is going to be 2x minus 1 times 4x minus 2, so I'm going to have 8x squared minus 4x, and then minus 4x plus 2. That's for this piece multiplied out. All I did was distribute. I refuse to say FOIL, so distributing. So now I'm going to subtract off this whole thing times 4. That's all that's left. 2 times 1 times 2 is 4. So this whole big piece right here is a 4. So that whole big piece is a 4. Okay? So I'm going to have minus 8x squared, 2x squared times 4, and then minus minus, so it's going to be plus 8x. That's kind of nice. And then I've got minus 2 times 4, so minus 8. Minus 8. Okay? And all of that is going to be over 2x minus 1 quantity cubed. Okay? So, here we go. 8x squared minus 8x squared, gone. Negative 4x minus 4x is negative 8x plus 8x, gone. So f double prime of x is going to wind up with 2 minus 8, which is going to give me a negative 6 over 2x minus 1 cubed. Finally, so I have my f double prime as 2, sorry, let me rephrase that, as negative 6 over 2x minus 1 cubed. Now, what does that mean? Well, this is kind of strange because I can already look and see that I don't have anything up on top that I can set equal to 0 and solve. So with that in mind, I've got kind of a strange looking function, I can already tell. But let's go ahead and go through the work. I'm going to clear this so that I can see what I'm doing. Let's see, clear. Okay, and I'm going to rewrite it. So f double prime of x was equal to negative 6 over 2x minus 1 to the third. So Discontinuities, yes, the same discontinuity we had before. But what about f double prime of x equals 0 as an inflection point? Well, I'm just looking at it. When does negative 6 equal to 0? What values of x is? Never. So there are no inflection points. No inflection points means that the f double prime chart, skip it, because there are no inflection points to chart out. So 6, y values. I need to get the y values for my critical numbers and my inflection points, but there are none because there are no critical numbers or inflection points. So we're left with the last one, number 7, sketching a graph. Well, what on earth do I have to sketch? Not a lot. So all I have are 2 pieces of information. Okay? I know that I have, if this is 1 right here, negative 1 rather, and this is positive 1. Well, I know that I have a vertical asymptote at x equals 1/2, so we'll call that 1/2. Okay? So a vertical asymptote, but no inflection points and no horizontal slopes. How on earth can I have that? Well, I can have that if I have a function that looks kind of like, you can imagine something like this, and then maybe this, or vice versa. How in the world can we figure out which one that is? Well, we can do a little bit of detective work. I'm going to try to, oh, I'll just erase that. That's okay. There we go. Back to being pristine. So how do we figure out what it looks like? Well, a couple things we can do are, I want to see what the concavity is like to either side of this inflection point. Okay? Or the slope. Either one would tell me exactly what I had. That's not that bad to do. So if I look at this function though, negative 6 over this thing that's being cubed, it's really easy to get the concavity. So I'm going to sketch a little bitty chart of x equals 1/2 and pick a value, maybe x equals 0. If x is 0, this is 2 minus 1, which is positive, cubed. So I've got positive on the bottom, negative on top. So this is going to be f double prime of 0 is going to be negative, which means that, did I do that right? 1, 2, 0, minus, oh, 0 minus 1. I knew that didn't look right. 0 minus 1 is negative 1, cubed is negative 1. Negative over negative is positive. So this is concave up. And if I plug in x equals 10 here, doesn't really matter, f double prime of 10 is going to equal, well, what does it look like? Very much positive in the bottom, negative on top. That's a negative, so that's going to be concave down. So what do I have? I've got something that is concave up like this, and something that is concave down like this. Okay, so it's going to be going like this and like this. How, where, what? Well, I now have to do a little bit of detective work. This is a very strange function. You normally don't run into this very often, but I need my original f of x to be able to tell where things are, what's going on with this function. So my f of x was equal to, it was a very strange function right from the get-go because it was x squared minus 1 over 2x minus 1. Okay? So this thing was equal to 0 when x squared minus 1 is equal to 0, which means x equals negative 1 and x equals positive 1. What are those values? Well, those are the values that I get for when my y value is 0. These values of x make the y value 0. So what are they? They are where I am going to when I'm graphing this out, x0, y0, x1. So let me just write it like that. -1, 0, and 1, 0. What does that look like? Well, right here and right here, what's happening? It is crossing the axis. So I'm getting this. Assuming I can draw without that big thing at the end, I'm going to be doing this right here. Okay? And this one, since it's concave down, has to be doing this. Something like that. Okay? Now, that is just the way that you have to do a little detective work when you don't wind up getting any horizontal slopes or inflection points. This is a little rough right here. I should probably clean that up just a bit, so make a nice smooth graph. And so that's it. That's what the function looks like. We've got a lot of work here to find this very simple result, and if you want, you can graph it on your calculator, and I think you will find that it agrees fairly well with what we have sketched here. So that's the process for that one. So let's clear this and do one more example. So here we go. Clearing the screen. Okay, so this next example looks very strange, but it's not too bad. So we've got f of x is equal to, I've got x times x minus 4 cubed. Okay, this is a very unusual form to see something in, but it's not impossible to deal with. We can knock this out. So first things first, let's go ahead and think about, are there any discontinuities? And if I multiply this out, this x minus 4 quantity cubed, and then distribute the x, I'm still going to have a polynomial, so there are going to be no discontinuities. Well, that's good to know. And then for the second one, where I'm looking for the critical numbers, well, I need f prime of x, right? So what is f prime of x going to be? Well, this is a product, right? There's a product x times this quantity. So it's going to be the first x times the derivative of the second, which is going to be 3 times x minus 4 quantity squared times the derivative of the interior, 1. And then plus the second, untouched, x, not s, x, x minus 4 quantity cubed times the derivative of the first, which is 1. Alrighty? So we're going to get f prime of x is equal to, well, this is going to be 3x times x minus 4 quantity squared plus x minus 4 quantity cubed. Okay? So now I can take this expression right here and look for my critical numbers. So well, this is as good as it gets. Part A, do I have any discontinuities? Nope, this is still just a polynomial, so we don't have to worry about that. Now what about f prime of x equals 0? Well, that is going to imply that 3x times x minus 4 quantity squared plus x minus 4 quantity cubed is 0. Alrighty, what do both of these have in common? Well, they have an x minus 4 quantity squared in common. So x minus 4 quantity squared times, so I'm going to have 3x from this one, and then plus x minus 4 on this one. Does everyone see where that came from? When I factored out the x minus 4 squared from the x minus 4 cubed, I'm just left with x minus 4 right here. And I can kind of put that in parentheses to make it a little more obvious. This is to the first. That's what's left. Okay, equals 0. Now I can set each piece equal to 0. So this becomes x minus 4 equals 0. And 3x plus 4x is 4x. So 4x minus 4 equals 0. So this means that x equals 4 and x equals 1. Those are our two critical numbers where we have horizontal slopes. Alrighty? So that's not too bad to have. And the next thing we're going to do is check in on the third step, which is going to be to make the f prime table. So let's go ahead and I think I'm going to clear that and start with that. Clear. And now for step 3, I want to make my chart. So I've got, this is the f prime chart. So I've got 2 locations I need to look at. So I'll make it a little bit longer. I've got x equals 1 and x equals 4. Okay. And my f prime of x was equal to, let's see, it was 3x times x minus 4 quantity squared, and then plus x minus 4 quantity cubed. Okay, so I've got that, and now all I have to do is do some test values. I need a value less than x equals 1, but x equals 0. So f prime of 0 is going to be, well, this whole thing goes to 0 since I put a 0 here, and this one becomes negative 4 cubed, which is going to be negative. So I'm heading, I don't have a whole lot of room here. I probably should put that a little bit further down, but I've got a downward slope right there. Okay, and so now I'll need a test value between 1 and 4. How about x equals 2? So f prime of 2 is going to give me, well, let's see, I'm going to get a positive here. I'm squaring this, so no matter what it is, it's positive. So this whole term is positive, and it's going to be somewhere along the order of, let's see, 6 times 4, so 24 right here. And this is going to be 2 minus 4 cubed, which is going to be negative 2 cubed, which is negative 8. 24 plus negative 8 means this is positive. So I'm going to have a slope that's going up. Okay? And then finally, a test value that's greater than 4. How about x equals 10? Alrighty, so I'm going to have 30 times, and this is going to be positive itself. So let's see, it's going to be 30 times 6 squared is 36. That's a very large number. But contrast that to 6 cubed. Wait. What is that value? Actually, I'm going to do that out because I'm not liking 30 times 6 squared, which is 36. And then plus, well, that's going to be 6 cubed. 6 cubed is 36 times 6, so 216. Wow, that one wins. That would be a negative 216. That one's still larger, so this is also positive. Well, that's interesting. F prime of 10 is positive, so it's also going up. I was not expecting that. Okay, so I know what this is right here because I remember what happens when we have a horizontal slope and it's the same slope on both sides of it. We are going to have an inflection point right there, and it's going to look something like this when I graph it, where this is a horizontal tangent. Interesting. Alrighty, so now that I have found my chart, I've got my different slopes for all the different intervals. Now I can go to step 4, and that is my let me kill that. That one is for my inflection points, which is, it needs the f double prime. So here we go. F double prime of x is going to be the derivative of what we have up here. Well, we've got a product here, and we've got a power rule here. So let's start with the product. So it's going to be the first times derivative of the second. So 2 times x minus 4 to the first times 1. That's the chain rule. So I have to take the derivative of the interior, which is 1, and then plus the second, x minus 4 quantity squared times derivative of the first, 3. And then that's going to be added to 3 times x minus 4 quantity squared times 1 again for the chain rule. Alrighty, so looks like a lot of work, but it's not too terribly bad. So what do we have here? I'm going to keep this x minus 4 as is. So I'm going to have 6x times x minus 4. And then I'm going to have plus 3 times x minus 4 quantity squared. And then right here, I'm going to have another 3 times x minus 4 quantity squared. So I can combine these into 6x times x minus 4 plus 6 times x minus 4 quantity squared. That's not too bad. Alrighty, so now that I've got that written, I can look for my inflection point. So part A, are there any discontinuities? Nope, no discontinuities, that's a polynomial. So if I'm looking for my f double prime of x equals 0, that implies that I get 6x times x minus 4 plus 6 times x minus 4 squared equals 0. Alrighty, what can I factor out? Well, I can factor out a 6 times x minus 4. Okay, what's that going to leave? Well, it's going to leave an x for the first term and an x minus 4 for the next one. Does everybody see where that came from? When I divide x minus 4 squared by x minus 4, I leave x minus 4 behind. So that's equal to 0. So now I can set each piece equal to 0, and again, I'm going to get, for my critical, I shouldn't say critical, my inflection points, the values at which f double prime equals 0, I'm going to get x equals 4 for one of them, for that piece, setting it equal to 0, and this piece is going to be 2x minus 4 equals 0, so x equals 2. Alrighty. So we've got some really strange behavior here. This is interesting. So now I have my two values that I can build my f double prime chart with. So let me clear this. First of all, let me write all this down so I don't forget it. So let me pause this. Alrighty, so let's see here. Clear that. And this is going to be step, what is it, 5? Yeah, step 5. I'm doing my f double prime chart. Okay, so I'm going to have two values to look at. I've got x equals 2 and x equals 4. Okay, and my function, my f double prime of x was equal to, let's see, it was 6x times x minus 4, and then plus 6 times x minus 4 quantity squared. Okay, so I need a test value less than 2. How about 0? X equals 0. If x is 0, this term drops, and I'm left with 0 minus 4 squared. It's positive times a positive. So f double prime of 0 is positive, which means I have concave up. Alrighty. Now, for between x equals 2 and x equals 3, a value, maybe x equals 2, x equals 4 a value, maybe x equals 3. So f double prime of 3, what is that going to give me? Well, I'm going to have a positive 18 here times negative 1. So negative 18 plus, this is going to be positive 1 times 6. So negative 18 plus 6 is definitely negative. So I'm going to get concave down between 2 and 4. And finally, a value out here, oh, I don't know, x equals 5 maybe. 30 times 1 is going to be 30, and then 6 times 1 is 6, so it's positive all the way around. So f double prime of 5 is positive. Okay, so now that I've got that positive, I can say that it's concave up on that interval. All right, last thing before I can start graphing, y values. Okay, so the first y values I'm going to look at are my critical numbers. Okay, and those critical numbers were at x equals 1 and x equals 4. Okay, so f of 1 is going to be, well, what was my original f? My original f was f of x was equal to x times x minus 4 quantity cubed. Okay, so f of 1 would be 1 times negative 3 cubed. Negative 3 cubed is negative 27, so this is going to be negative 27. So the point's going to be at 1, negative 27. Okay? Now x equals 4. I have to do f of 4. Well, that's not too bad. F of 4 is going to be 0 times 4, which is still 0, so that's 0. So this is located at 4, 0. Okay? Now I need my inflection points. Okay? So those were located at x equals 2 and x equals 4. I already know my x equals 4, so I know that point's located at 4, 0. And it was an inflection point after all, which is exactly what we thought we had to have in order for both slopes to be positive on either side. So what about x equals 2? Well, f of 2 is going to give me 2 times negative 2 to the third, which is negative 8. 2 times negative 8 is negative 16. So this one is at 2, negative 16. Alrighty. Now let's sketch it. So here we go. That 7. So let's go with, I'm going to make this kind of stretched because it's not going to make sense otherwise. So something like this. Okay. So what kind of points do I have? Well, I've got, let's see, 4, 0. So 4 zeros. So I can go out 1, 2, 3, 4. Okay. And I've got negative 1, 27. So I'm just going to call this negative 27. And I will call this one maybe negative 16. Okay. So now let's fill in all of the points. We had for our horizontal slopes, our critical numbers were located at, we had one at 1, negative 27. So there we go. And then we had the other at 4, 0. So here we go, right here. Okay. Now, what were the inflection points? Well, the inflection points were located at 2, negative 16. So, let me write these out too, by the way, so that we have 1, negative 27, and 4, 0. Wow, that turned into a 9 somehow. Try that again. 4, 0. Okay. And then 2, negative 16 was the inflection point. Okay. Now, what did all the pieces look like? Well, to the left of x equals 1, the slope was coming down. To the right, it was going up and up on both sides of this x equals 4 value. And then for my concavity, I had from both 4, the x equals positive 2, I had a concave up slope. So this was concave up. Then it went concave down. And then it went concave up. Okay. Now how can I resolve all this? Well, the only way I can really resolve this is I'm going to have a slope coming down like that. And then it switches concavity like this, goes horizontal, and then continues up. This is what the function has to look like. And so this one a little bit messed up right here. Let me try to connect that a little smoother. There we go, something like that. It's going concave up, and then right here it switches to concave down, and then it switches again to concave up. Right here we have a horizontal. Right here we have a horizontal. That is exactly what the function looks like. So there we go. Whew, wasn't that fun? So here we go. Homework. So homework, try the following. Okay, I know it seems like a lot, but you need practice. So homework, and this is from section 3.4, is going to be 18, 32, and 42. Give them a good try at least. And as always, check Desmos afterwards, see if you got it right. Or check it during if you want to kind of verify that you're doing things right all along. Alrighty, I will see you next video. Take care, stay safe. Bye-bye.